My best guess for the way that Chapter 9 is going to work out is that today's what? Thursday, Friday, Monday, Tuesday. We're going to do 9-1 today, 9-2 Friday, 9-3 here. We might as well just quiz out on Tuesday. To be like I'm saying here, hold on. What I'm saying here is that a lot of the stuff in 9, there's like 2 halves to it. The first half is some pretty basic graphing, direct variation stuff. The second half deals with a little bit more rational expressions, where it gets a little funkier. So it's a nice break point. Phoebe.
The magicals are going on a school board thing on Tuesday?
Well, you'll have to take it before, or you'll have to take it the day you get back. So it sucks. I know, it stinks. Are you going to say it too? All right. Gotta love field trips. Yes, sir.
I'm on here Tuesday, so can I take it on Monday?
I don't think that'll be a problem as long as I have it done and written by then.
Oh, can you take it during 25
You only have 20 minutes to take it, so hopefully you can get it done in 20 minutes.
Wait, it's a whole period type of quiz?
It's 4 days from now. We'll worry about it when we get back.
Maybe just remember, obviously 6.9 was easy, but would that be on there too? Like on frozen?
Probably. I'll probably build that into there. So let's get into this. We're talking now about what are called inverse and joint variation. Believe it or not, you guys have actually worked with variations in the past. You guys have worked with something called direct variation. If you go back way, way, way back in the back of your minds, somewhere in the cerebral cortex, part of the brain, proud of you, you would have learned something about slopes. Long, long time ago in a galaxy far, far away. You learned something about slopes. When you first learned about slopes, you learned them as what they called direct variation. Direct variation was slopes on a line without a y-intercept, where your y-intercept was 0. Y equals mx. Y equals 2x. That's direct variation. What happened here with direct variation is that the correspondence between x's and y's, when you pick an x, you multiply it by something to generate the y value. So if it was y equals 2x, your table set of values would have been, x's, generate your y, 1, 2, and 3. It would have been 2, 4, and 6. It looks something like that. And you did that with slopes long, long time ago. And bless you. The new thing is called inverse variation. Well, what is the inverse of multiplying? Dividing. So instead of it being y equals k times x equals y equals k divided by x. It's some constant.
Why is this
It used to be M and they decided to make it K just because they wanted to.
Yep.
Yay.
So what happens here is you get this inverse variation, where as you're going through this style stuff, instead of it being divided out, or instead of being multiplied through, you're dividing stuff. It's a relatively simple scenario. There's not a lot of craziness really involved in this. It's just a matter of, can you understand how it looks? Okay. They always say that your constant here when you're talking about inverse variation is not equal to 0 because then you have no variation. It's just y equals 0. Makes sense?
Yeah.
That's why they put it that little caveat there. So when we're looking at inverse variation, you say it like this. Y varies inversely with x. When you see y varies inversely with x, that basically means y equals something divided by x. You'll see it written with different letters. Z varies inversely with t. R varies inversely with p. Whatever. That inversely just means divided by the next variable. Okay. That's y varies directly, means they're multiplying. Inversely means they're dividing.
Will we see directly?
Yeah, you'll see it mixed together because direct variation and the joint variation kind of mixes them a little bit together, and we're only about 3 minutes in, so I don't know about everybody else. Anybody else stressed?
I'm doing great.
All right, cool.
Well, there's no number.
No numbers yet, yeah. This is just algebra. I'm just messing with you. She hates me, I know it. So what happens is, to tell whether or not these things are direct variation versus inverse variation, it's basically the same scenario. What you're always going to want to do is just get y by itself. When you solve any of these equations for y, you'll be able to tell whether or not there's a direct variation, things are being multiplied, or an inverse variation, where things are being divided. Okay. So if I'm looking at this first example, y divided by 5 equals x, I multiply both sides by 5, and you get y equals 5x, which is direct variation. Good. Okay. Excuse me. On the next one, you have y equals x plus 2. It's nothing.
Let's go.
Yeah, it's
Whoa.
nothing.
Did you not hear me say it?
I didn't hear you say it, sorry.
Yeah, you kind of were like,
It's because of that plus there.
you were like,
I was like,
We're talking about direct or indirect variation. We're talking about just straight multiplying or dividing. We're not worried about any constants at all. It's just straight out like that. Okay? Now, when I get to the next one, x times y equals 4, what is that going to be? Inverse. Indirect, yeah. Inverse. You get y equals,
why don't I just indirect?
I don't know. Maybe they don't want to be in a roundabout kind of way. Thank you. Yeah, I know it's bad. Okay. And that one would be a an inverse variation. Okay. What we're going to wind up doing is, the reason that we're talking about direct and indirect variations in these things is that eventually, like starting tomorrow, we'll start graphing those. Yes, ma'am?
Does it have to be the constant or is it?
Yes. What do you mean? If it's like x over, if it's x over 4, then it's not going to be, because then it would not be inverse, it would be direct. Because if it was x over 4, bless you, is that the same thing as 1/4 x? That would be direct variation then. Does that make sense? It's a great question. So what we're going to do here is we're going to look at these tables. And this is where it comes back into, you know how to interpret data. So when we're talking about looking at a table, we're looking at x's and y's. In this case, the top thing is w and h. Think of this as x is to y. All right. Now, if it's direct variation, if it's going to be direct variation, you're going to get an equation y equals k times x. If it's inverse, it would be y equals k divided by x. Here's where it gets interesting. If two things have a direct variation, that, bless you, that value of k remains constant. Same thing with inverse. So what you wind up doing here is you try to check each one of those sets as an x and y to solve for k. Here's what I mean. If I'm looking at this first column as my x values, second one is my y values, I'm going to do this. Does 9 equal 2 times something? Does 4.5 equal 4 times something? Does 3 equal, what was it? 6 times something. Is this value of k staying the same each time? Well, how would you check? You just check in your calculator. Here you would get what? 4.5.
4.5.
Here you don't get 4.5. Here you get 1/2.
That one would you get 1 point? No.
It'd be something, I don't know.
Yeah, I don't care.
I don't really care. Exactly. I can tell right away because just by skipping around, I'm not going to get that same value. What if I check the other stuff, other type? Does 9 equal something divided by 2? Does 4 equal something divided by 4.5? And so on. When you do that,
Yeah, wouldn't it be 4.5
Divided by.
oh, did I flip it? Sorry.
Wait, what?
Sorry.
Oh,
It'd be 4.5. Sorry, I didn't mean to flip in there. When you solve for k going through that value, do you get the same value each time?
18.
You get 18 each time, right? So by looking at this table then, you'll be able to tell by just checking these quick little scenarios whether or not it's going to be direct or indirect. Or indirect, you guys got me on that. Inverse, thank you. You're able to tell whether it's an inverse variation versus a direct variation. And then when you did that, you were able to figure out that the k value here, what'd you figure, was what, 18?
Yeah.
So your answer would be y equals 18 over x. You're doing that table modeling like you did yesterday with your calculator, but you're doing it by hand with something a little bit easier. You don't have to find some crazy polynomial function. You're just writing a quick little equation. All right? Not bad, is it? For now, well, try one. Try this one.
And if we're at the on the T here, can we just write out if you want?
What do you mean?
It says R.
You can say R, then it would be R equals K times T, or R equals K over T.
No, like he's saying, like, can you just?
Oh, substitute? Yeah, you can want to do that, that's fine. I'm just putting them in there because you're going to see it written a bunch of different ways. You just think your first one generates the second, that's fine. Weird. It's so weird. I always leave my coffee back there. Whoops. When you do that right away, do you realize that it's not going to be direct?
Yeah.
Okay. So if you check the inverse, then
I didn't. I'm doing it the wrong way. Wait, no, I didn't. I did it right.
you should be able to find out real fast that it works this way.
This one.
Your k value is what? 300. So your equation is?
Oh, yeah.
All right, now try that one. You didn't have to set much or not.
Oh,
Yes. I didn't see the top.
all right.
There's a problem. Last one like this, and then we'll go on.
So I'm gonna have another night to do it out loud. Probably not gonna do it. I started it, because I was like, this is a long, I should probably get it started on it, and then I didn't do it.
Humanities test?
Which one do you wind up with here? Correct. What is it? K value is 7. We okay on that? No, once you start going through a couple, you should once you get to this, you get a couple, you start to see if it's the same value, you'll probably get it.
I get 12 and all
Also,
my
you might, but I usually
So,
just do one.
let's make it a little bit more interesting then.
What's it?
Let's write out the equation when you're given specific values. And this is where the wording, you have to be careful how you write it. So the variables x and y vary inversely.
Alright.
When y is 8, x is 3. So x and y are varying inversely, so that means that we have y equals k over x. It's just writing equations. Yeah, this is where it gets interesting. And they say that when y is 8, x is 3. So let's see. Y is 8, x is 3. What is y when x is negative 4? What do you have to solve for? K.
Okay.
What is, and you already said this, Phoebe, what's the value of k in this equation?
24.
24. So here we know that the k value is 24. You wind up having to reuse that here. They give you the scenario to start with. You have to find that constant, reuse it to solve again. So then you figure out that y is going to equal 24 over x. So y is 24 over -4, which is
Negative
6.
6. What happens again, the scenario for these types of problems is you're going to solve for that constant and then resubstitute it. Okay? You solve and resubstitute and go from there. You did that way back in algebra when you first learned about slopes. It's the same wording, you know, x and y vary are direct variation and blah blah blah. You did that stuff out. We did that a lot. We might have stopped doing it by the time you guys got into algebra because it wasn't a necessary thing to be able to look at that variation back then. So we just started going right into the actual how do you solve for it. So what we're going to do with these things is just same idea. We're going to write out a few of them to figure out what y is. So they vary inversely, same scenario, y equals kx. Here's your first two variables. What do you have to solve for? Then what do? You reuse it for the second. Take a second to figure the algebra out. You should be happy with 1- and 2-step algebra problems for a change. See if you're on the right track here. Is your constant 20?
No.
5.
5. Yeah.
5. Oh,
I still got
It's 5.
Yeah, my goodness.
Stop laughing at me.
do you divide by a half or multiply by a half?
5.
No, you
No, you divide.
Why would you?
Right.
You want to equal something.
Yes.
I don't know. Because you're dividing by a half. How do you divide by a half? You multiply by a half. What's half of 10?
5. Basic math, what?
10, right? What's half of 10?
5.
I'm just impressed that I had $10 in my wallet. I'm not buying a pork chop dinner.
Yeah.
So if k is 5, when you just resubstitute through,
And it solves itself.
5 halves, 2.5. Okay, not bad. All right, so let's mix this up with the joint variation stuff and how the wording goes here. Joint variation is going with more than one variable now. Joint variation, don't write all of this out.
Yeah.
Joint variation is nothing more than the product of 2 or more variables. That's it. You're multiplying more than one thing. For example, you can say z varies jointly with x and y. And what that means is the following. It's a direct variation. When they have direct variation, it means you're just multiplying straight across. Z equals some constant times x times y. All that is saying is that there's a joint variation. When it's a joint variation thing is that you're joining more than one thing together by multiplication. That's all it is. You're just multiplying more variables together. It'll be written sometimes as z varies jointly with the square of x and the cube of y. So if z varies jointly with the square of x and the cube of y, what would that look like? Yeah, it'd be z equals k x squared y cubed. Does that make sense? Yes, ma'am.
Why is K in there if it just says with X and Y?
Because it's this joint variation. That means there's always some constant being multiplied in.
Oh.
Okay? That it's the same idea as that direct variation. They're varying directly because there's something being multiplied to get you the value. It's remember when we did that last that graph with the function of x was your zeros. You had that multiplied term of an a. That a value is similar to that constant. Does that make sense? Yes, ma'am.
So if it's inversely,
We'll get to that. It really depends on the wording, and it takes a couple minutes to get used to it. And it so happens I have examples.
Oh, okay.
Can you write all this
This is
out?
in your book. It's verbatim out of your book. So y varies directly with x.
Y times X.
Y? Huh?
Y is that Y over.
Why equals X?
Oh.
Y varies directly. Y equals kx. Straightforward. Okay. Y varies inversely. Well, we just did those two.
Y is K over X.
Y is k over x. Now when it gets into that joint variation, when it's talking about it, like we were saying again, joint variation, if you want to think of it as joining more than one variable together by multiplication. So if z varies jointly with x and y, z is, what do you think? Z is kxy. It's right out of your book. This is on page.
Sounds good.
You know, it's section 9.1. I know that. Now, if y varies inversely with the square of x, inversely tells you what's going to be the operation on one side. K over something. Good. What's it going to be over?
X squared.
X squared. Very good. All right. Inversely is telling you division. Yes, ma'am.
Is there going to be like jointly and inversely?
I mean directly and inversely, like the next one I have. That's up there. That's kind of what Izzy was getting at too, I think. So if you look at this one, it says z varies directly with y and inversely with x. So it's direct with y, inverse with x.
Maybe z equals ky over x.
Very good. That's all it is. And like I said, the toughest part of this is just getting used to how it's written. That's all. If you remember, direct is multiply, inverse is divide, you're going to be okay. Jointly just means there's more than one being multiplied or divided together. Now, when it comes to these types of problems, I don't know if we're going to have so many of the equations, or I should say like the ones down at the bottom here, where you have the squares and stuff. I don't know if you're going to have to do the solve for k value with the square roots and all that. That just gets to be pretty nasty. It's more or less, can you write out the formula? Does that make sense?
Yeah.
I don't want to give you too many of them because there's only so many.
Oh,
What's
I
that?
get it.
Maybe it's like you want to be
Well, I could also, I mean, you think about it, I could say z varies inverse, or z varies directly with the square of x, inversely with the cube of y.
Alright.
Z equals kx squared over y cubed. I mean, there's only so many variations, but there's only so many ways you can write these things out. We all good? All right. So, this is boring. I don't want to do all that. Switchboard. Do these. I gave you the odds. You can check them. So I want to make sure you guys are getting these right. Tomorrow we'll start with graphing, and basically we're going back to graphing. It's going to look a lot like a hyperbola, believe it or not.
What's on
Yeah. All right.
First part of